Alright, so in section 2.3, we're going to look at quick graphs of linear equations. Alright, so instead of having to create a table of values to graph an equation of a line, we can use two other quick methods to graph any line. And the two ways that we can do that is using the slope-intercept form and standard form of a linear equation. And so these two will save time, especially if you're trying to get something done faster. You can use these two methods. You can still decide to use the table method if you want, but we do want to introduce this part to you. Right, the first part here is the slope-intercept form. And slope-intercept form of an equation of a line is y equals to mx plus b, where the m, that part right in front of the x, whatever is in front of the x, is the slope. And the b is what we call the y-intercept. And if you ever watched American football, NFL, you'll notice that you hear about interception, right, where you cut something off. Well, the y-intercept is where you cut across the y-axis. Now, we're going to need this a little bit later, but the x and y represent the ordered pair. We can use that to help us later on in solving graphical equations and whatnot. All right, so we have an example here. All we need to do here is determine the slope and the y-intercept. So what is the slope for part A? You can answer it, and then I'll show you your answer. So what is the slope? What is the y-intercept? All right, hopefully you said m is equal to -2, and your b, your y-intercept, is 3. Okay, how about part B? What is the slope and the y-intercept? If you said m equals to -5, you are wrong. And the reason why, it's always next to the x. Right, so I just rearrange that. Remember, addition and multiplication in terms are associative, so we can rewrite them. You're looking for the mx, right? It's a rate of change, like miles per hour, etc. So m equals to 4 here, and b would be equal to -5. All right, if you look at part C, you notice that it's not in y-intercept form. And so this is where our understanding of solving equations comes in, and what we did earlier, how to solve equations in chapter 1. So we need to get that y by itself. So what we'll do is do the opposite operation with the number that we want to move to the other side of the equation, and that's the 3. So since 3 and y is multiplication, we will divide, and we divide by the same number. What we do to one side of the equation, do to both sides. And we can either divide everything by 3, but since we want it to be in slope-intercept form, we're just going to divide individual terms by 3. All right, so the 3's here cancel, and we're left with y equals to 2/3 x plus 9 divided by 3 is 3. And that's the answer in slope-intercept form. But we want to know what m is equal to. M is 2/3, and b is equal to 3. That's your y-intercept. All right, and that last one there, uh, notice that this one is even more out of place. We're going to have to move more than just one term here. So we want it to be in y-intercept form, slope-intercept form. Those are synonymous phrases. We want the y by itself, and because it's positive, we leave the y on the left side. There's no need to move it to the right, or else you're just creating more steps. So let's start with the -4x. Because we're moving the whole term, we're going to use positive 4x to cancel. And what we do to one side of the equation, we do to the other. So that means on the left side, we're left with 2y. And then we have, and we want to keep it in order. You don't really have to, but we're going to keep it in order. So 4x subtract 8. And then now we have something like part C. So we're going to divide both sides, everything by 2. And this is easy because these are all common factors. So 4x, 4 divided by 2 is just going to be 2x, and 8 divided by 2 is 4. Right, once we do that, we just need to determine the slope. Your m is equal to 2, and your b, your y-intercept, -4. All right, now, excuse me, sometimes they might not have b, they might have a different letter, but just as long as you know that the slope is always multiplying the independent variable, the domain, right, the input. Whatever goes on the x-axis is multiplied by the slope. And the y-intercept is always the constant, the number that's by itself. Okay? Now, one thing about the y-intercept is going to be 0. So if you y-intercept cuts on the axis, the y-axis, and the only way that can happen is if x is 0. So this is actually 0 y-intercept. Even if it's down here, it's going to be 0 negative y-intercept, right? Because it's crossing the y-axis, and the only time that can happen is if the x-axis is 0. So keep that in mind. That's one way you could find the y-intercept as well, is to set the x value equal to 0. Okay, so let's go ahead and do this example. We're going to write the equation of the line given the slope in the y-intercept form. So remember, this is y-intercept form. The slope is given and the y-intercept is given, and this is very straightforward. Simply y equals to 4x. This is a negative 3, so subtract 3, and you're done. And same thing here. We have m equals to negative 2/3 and b equals to 4. So that's y equals to m negative 2/3 x, because you're multiplying, plus a positive b, 4. So negative 2/3 x plus 4. And that's how you can take anything based off of what you're given and find the equation. All right, let's go to the fun part of graphing. Now you're going to need a ruler. It's hard for me to use a ruler on this laptop, so my lines might not be as good as what your lines are expected to be. So you want to use a line. Remember, in order for me to put my points on here nicely, I'm going to use axis. But when you plot your points, make sure you actually use dots, not the axis. All right, so we're going to graph y equals to 2/3 x plus 4. And we already kind of talked about slope briefly, about the rise over the run in the previous lesson, or 2 lessons ago. So first thing, we want to identify our slope. Our slope is m is equal to 2/3. Remember, that's the same as rise over run. And I do want to introduce something else, our concepts of negative numbers, dividing by negatives. Negative 2/3 is also the same thing, right? A negative divided by a negative is positive. We're going to use this to help us out in our graph. And then we also have our b. Our b, or our y-intercept, is 4. So how does this look when we actually graph? Well, first we want to go to our y-intercept. You put a dot. So we have our y-intercepts 4. And then from there, we can use our rise over run. Our first rise over run is 2/3. So we could go up 2 units to 6, and then over 2, 3 here. Now, the negative 2 over the negative 3 is equivalent. It's an equivalent fraction, which means from my y-intercept, I can go down 2 for negative 2, and then to the left 3 units, 2, 3, and now I can get a line on my negative, my 0, and positive, just like I do with the tables. Remember, we would choose 3 values at the least, a negative, a 0, and a positive. And so understanding that connection between the fractions can help us to draw a nice line, and there we have it. We normally would label our line if we have multiple lines there. So that's the line y equals to 2/3 x plus 4. All right, just remember, use dots and use a ruler. Okay, let's try another one. Notice this one is not in the form, and so this is where a little skill of solving for y can come in. Right, we want y by itself. We can move the whole term, so the opposite of a positive 3x is negative. What you do to one side, do to the other. And so what we get here is the 3x's cancel, y is left on the left side, and I like to put my x's first, so negative 3x plus 1. So then we can graph by determining the slope. Remember, any number can be written as a fraction as that number over 1, which is also equal to, if I was to change the signs around, if I was to negate the top, it would become positive 3, and if I was to negate the bottom, it would become negative 1. So those are two equivalent fractions. And remember, rise is on the top. So first I need to find the y-intercept, and that's a positive 1, which will be here. Our x-axis are going by ones. So from my mark here, yours is a dot, remember, we're going to go down 3, the negative 3, so down 1, 2, 3 to negative 2, and then it's a positive direction to the 1, so here. And you can see already this is a downward slope, and that's given because our slope is a negative. And then from the y-intercept, we could use this one. And from the y-intercept, go up 3 units, 1, 2, 3 to 4, and then to the left 1. And now we see our negative slope, as we can identify there. And we can draw a straight line through our points, use a ruler, and put our arrows to signify that this keeps going. All right, and that's how you can graph a line using the slope-intercept form. All right, so in example 2, we're going to use the slope-intercept form in a real-life situation. So this one is about placing an ad in a newspaper. It says the cost, C in dollars, of placing a color advertisement in a newspaper can be modeled by the following equation, where n is the number of lines in the ad, and it asks you to graph the equation and then answer 2 questions there. So let's start with the graph. We have C is equal to 7n plus 20. And we need to identify our slope. And our slope, remember, is whatever is being multiplied by the variable. So that's 7. And we want it in fraction form. So any number can be written as a fraction as 7 over 1. And then because we might need to go both directions, that's negative 7 over negative 1. Right? We want to make sure both the numerator and the denominator have been negated. All right, so then our y-intercept is going to be positive 20. So this should be an easy graph. I thought I had a graph here. Looks like I forgot to put it on here, so I had to graph this out by hand. And because I don't have a ruler, it may not look as neat as yours can, but let's see how neat I can make it. Now, it also helps before you draw it to get an idea of this slope. This is a positive slope, so it's actually going to go this direction. And so we're going to need both quadrants to help us here. Sometimes you only need the first quadrant, but that's when you have a negative slope. This one's positive, and so we're going to have to utilize more than just one side. So let's go ahead and draw that out. So I'm going to draw our x and y, and instead of x we have n, instead of y we have c, and this will be our origin. Just come down a little. Alright, so because I have a small one here, I'm going to go up by 4s to get to the y-intercept. So 1, 2, 3, 4, 5, 6 should do it. And so that's 4, 8, 12, 16, 20, and 24. Okay, so if we start off at our y-intercept, so that's 20, we're going to have to go down 7 units, right? We're going to have to use this one. Going up 7 units is not going to look too sharp. So we're going to go down 7 units, and to go down 7 units, well, that's 4, and then 16 minus 3 is going to give us 13, so like 1 above that. And we're going to go down 7 and 1 unit over. So 1, 2, 3, 4, 5. All right, so we're at 13, and so that's going to be about here. And then we're going to have to go down 7 units again. So 7 from 13, or 13 from 7 rather, is going to give us 6. So this is going to be like about halfway here. And so we're going to go down 6 and then over 1 unit. And now we're at 6. And then since we're at 6, we're going to go down 7. So that's going to take us to the negative 1 range here. So down there, and then 1 unit over would give us a 2. Right? And so we're basically getting an idea of what that graph looks like. I'll change it to blue and try to draw it through your points. If you use a ruler, you can hit every point pretty nicely. Mine's going to be a little bit crooked, but sadly, because I don't have a ruler to draw out my graph. But yours should go straight through those points nicely with a graph paper and a ruler. All right, so we have our equation. It says, what do the slope and c-intercept represent? So that's all they want. Your slope, 7n, is the number of lines, and your cost and n. So that's your n. Your slope basically means, let me write it here. Your slope, remember, it's rise over run. So your rise, so your slope is rise over run. And remember, your rise represents your y values. And so your y values is the cost. And then your n, which is your x, is your run, and that's number of lines. So I'll just put I know that you might think hashtag, but in my generation this used to be numbers. So number of lines. All right, so that's cost per number of lines. And so that's $7 per lines in the ad. So that's what your slope means, $7 per line. And then your C, well, they tell you that already. Your C intercept just means that it costs $20 flat out. So that's what your C represents. Your Y intercept, I'll just put Y enter. So your Y intercept represents $20 flat rate. Right, so that means even if it's at zero, it's a flat rate. And technically, they might want the more positive side, but it'll just keep going up higher. So you just do plus 7 plus 1. So up 7 over 1, up 7 over 1. So your next point would have been 27 and at positive 1. Right? And you just keep doing that. But they didn't really want that much. They just wanted this one, the main answer of that. So $7 per line in the newspaper and $20 flat rate. So there you have how to do that one. Okay, so now we have standard form. To do standard form, the standard form of a linear equation is ax plus by equals c, where a cannot be equal to 0 or b cannot equal to 0, right? It just both of them can't be equal to 0. It's like one or the other or none at all. So you can graph equations in standard form by finding and graphing the x-intercepts and the y-intercepts, then drawing a line through the 2 points. This can be done by setting the x value equal to 0 and solving for y to get the y-intercept, and then setting the x value equal to 0 and solving for x to get the x-intercept. So graphically, to help this make sense of why we do what we do, is that the y-intercept happens when, remember we talked about this, when x equals 0. So if you set it equal to 0 and solve, remember our x and y in slope-intercept form represents our coordinate points. So if I substitute in there, it's basically like setting x equal to 0. And when I want to find the y-intercept, well, notice now that in order to, the x-intercept, notice that to find the x-intercept, my y value has to be 0 to come down on the x-axis. And so that's basically what we're doing in equation form. Remember when we started this chapter, we looked at mappings and tables. All of them are interconnected, and we can use our understanding of them to interchange. So if I wanted to graph this one in standard form, instead of solving for y and putting it into slope-intercept form, I can first find out what my x-intercept is. And to find the x-intercept, remember what you do is set your y value equal to 0, because when you're touching the x-axis, y is now equal to 0. And so that leaves you with 3x equals to 12. And if you divide both sides by 3, x equals to 4. So that means that this line will cross at x equals to 4 on the x-intercept. And then the y-intercept, similarly, is to set your x value equal to 0, because in order to touch the y-axis, x has to be 0. And so you would get 3 times 0 is 0, plus 4, 4y equals 12, and you don't need that 0 part there. So if 4y equals to 12, you divide both sides by 4, and you get y. 12 divided by 4 is 3. And once you do that, you just draw a line through that, and you are done. All right, so that's our equation, 3x plus 4y equals to 12, and done.